Right, we're carrying on with November 2021. And for some reason I've lost the first 5 questions, but we can do those again. Let's continue on anyway. So question 6 is done. The scientist studies hair color in mice. Mice have grey hair or white hair. In a first cross, a male mouse with white hair is mated with a female mouse with grey hair. All the offspring have grey hair. Right. Oh, right. We don't need that. Right. Oh, what's going on here? No, we've lost it. We've lost it. Right. Okay. Let's crack on with this then. What is meant by the term gene? So a gene is a section of DNA that codes for a specific protein. Done. Right? Section of DNA that codes for a specific protein. Yeah, just remember that. Right. State the phenotype coded by the dominant allele. Right. What they're saying is you've got a male mouse with white hair, female mouse with grey hair, and all the kids, all the offspring have grey hair. So the dominant allele must be grey. That makes sense, yeah? Yeah, this is what I was going to do here actually. Look. So what we'll do is we'll just make some assumptions here. Let's make some assumptions here. Right, so that is the male. He has white hair, so we'll put W, we'll put grey. Right, so what you end up with grey, white, grey, white, grey, white, and grey, white. And they've all come out grey, so that means that the... Oh my word, did I just do that? I did. So that means that the grey... What really clever that. The grey must be dominant. Right, now let's move on. A male mouse and a female mouse with grey hair were chosen from the offspring. So remember, all the kids here have got grey, white, grey, white. So what we do is we do a Punnett square. Let's do that again. So you've got the male has got a grey, white, grey, white. What they've done is, right, okay, let me just redo that. So they've done the big G equals grey and the little g equals not grey, which is white. That's how they've gone about it. So what we're going to do is we're going to do carry on with that. G, 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 G. So this is female. You end up with G, G. You end up with G, G. You end up with G, G. And you end up with G, G. Right. Right, you've got right. Some of the offspring of this second cross have grey and some have white. Use a genetic diagram to show the second cross. So let me get this read. 1, 2, 3 are going to be grey. So 3 are grey, and this one here, 1 is going to be white. Right, what have they said about a Punnett square? Let me just read. Okay, 3 to 1. So you should give the genotypes and the ratio of the phenotypes. So phenotypes is how, let me write that down. Phenotype is how they look or appear. So it's going to be grey to white. It's going to be 3 to 1. Right, okay. Right. They'll allow a Punnett square that we've done, and then to finish it off with this. Right, but we can say parent genotype is G and no, phenotype, should we say? Let's get rid of that. Phenotype, and then the parent genotype, they've only got a G and a G. Yeah. So you're going to end up with a G or a G, and then the offspring, phenotype will be, it's going to be either GG. So let me just put that down actually separately. Let me just move that there. Let me just move that there. Let me just move that there. Right, okay. You can end up with either GG, a GG. There's 2 of them, and then there's a GG. And then at the end of the day, you're going to end up with these 3 as grey, and this is as white. So it'll be in the ratio of 3 to 1. So the offspring, you'll have 3 grey and 1 white. Right, okay, what else is there? The scientist concludes that a mouse with grey hair could have 2 possible genotypes. Explain how the science could use a cross to determine the genotype of a mouse with grey hair. Ooh, that's an interesting one. Right. What you could do is get a mouse with white hair, homozygous, yeah, and breed it. If all of its offspring are white, if all of its offspring No, you want if all of his offspring not white, they won't be white. They'll be grey. Hello. Offspring are grey, then parent was homozygous GG because it's passed on the grey colour hair. If some of its offspring are white, then the parent was GG. So what they're trying to say is, if you've got grey hair, you can be either GG or GG. Yeah. Now, if you're GG and you cross with a white mouse, which is GG, right after that disruption. Hello. Let me get that. Right, okay. There we go. Right. If, however, the pen is a big G, small g, and you crossbreed it with a white mouse, you're going to end up with big G, small b, big G, small g, big G, small g, big C. All these are grey. However, with this one, you've got G, 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 small g, big G, G, small g. Only these two are going to be grey. So what they're saying is, so just try to understand this. What they're saying, get a white mouse that you know has got a GG, and then you crossbreed it with a mouse, and if they're all grey, you know the parent was GG. If some are white, oh my word, let's use a yellow. If some are white, then the parent was a big G, small g, because this is how you get the white-haired mice. Right, let's move on from that. Let's not worry about that. Sometimes it's easy to get stuck on them. I don't know how long it took me to figure that out. Albino mice have white hair. These mice also have pink eyes. They do not have pigments in their irises, so they are less likely to explore a new area when compared to mice with grey hair. This is an example of one gene having many effects. Describe how genetic control of most phenotypic features differs in this example. Right. So what that means is so phenotype or phenotypic features are usually controlled by more than one gene. Each gene has a small effect on the overall feature. Right, okay. So we've put the word, right. So most phenotypes are polygenic. That means it's controlled by more than one gene. Really, it's not as simple as black and white, or you could have more than one gene, more than two genes. It could be lots of genes, and scientists have not discovered everything yet. So, right. Most single genes only affect one phenotype. Only affect one phenotype. Right, okay. Leave it like that. That's as far as my understanding goes on that. Right. Right, we'll do this on the next question.